I wanted to go through a couple of standard error problems with you. This is a standard error word problem, just like the problem that I showed you in the video. This problem says that the heights of the 4 people in a small population are 50, 52, 54, and 56. I'm interested in what the mean height of this population equals, but I don't have enough time to record the heights of all 4 people in the population. So what I'm going to do is I'm going to randomly select a sample of 2 people from this population, record their 2 heights, and then calculate the mean height of my sample to estimate the mean height of the entire population. And this question asks, what does the standard error of the possible samples of 2 people equal? I'll explain what this question is asking. If I randomly select a sample of 2 people from this population, there are 6 possible samples that could be chosen. In other words, there's 6 possible combinations of 2 people that could be selected. I'm only going to get one of those as my actual sample. Each of those 6 possible samples of 2 people has its own sample mean. The standard error would just be the standard deviation of all 6 of those sample means. In the video I told you that the standard error is just the standard deviation of the sampling distribution. It's the standard deviation of the means of all possible samples that could be selected in the study. So we're going to go through both methods of finding the standard error. In the video I showed you 2 different methods. The first method involves calculating the means of all possible samples, and then calculating the standard deviation of the sample means. The second method is the standard error formula. We'll use the first method first. So the first step of method 1 is to find the means of all possible samples. And this question says we want the standard error of the possible samples of 2 people. So we know that we're dealing with possible samples of 2 people. That means that in step 1, we're going to sort out the population into all possible samples of 2 people, and then calculate the mean of each sample. It'll be helpful if I write the population over here just so we can see it. So the 4 people in the population have these heights. These are the heights of the 4 people in the population. Now let's sort this out into all possible samples of 2 people. There's going to be 6 of them. I'll explain why. To sort this population of 4 people into all possible samples of 2 people, we have to follow these steps right here. First, we have to start with person 1, and then pair person 1 with each person under person 1. So we need to pair person 1 with person 2, person 1 with person 3, and person 1 with person 4. So let's do that. So when we pair person 1 with person 2, we get 1 possible sample. I'm just writing down some ID numbers so we can keep track of the different people in the population. So sample 1 the first possible sample is person 1 and person 2. The second possible sample is person 1 and person 3. And their two heights are 50 and 54. The third possible sample is person 1 and person 4. Their two heights are 50 and 56. So now we've finished writing out the first three possible samples. At this point, we have no one left to pair with person 1. So we'll move down to person 2, and we'll pair person 2 with every person under person 2. So 2 and 3 will be one possible sample. Their two heights are 52 and 54. And now the next possible sample will be person 2 and person 4. Their two heights are 52 and 56. And we don't have anyone left to pair with person 2, so we'll move down to person 3. And we'll pair person 3 with each person under person 3. The only person under person 3 is person 4, which means that 3 and 4 will be our last possible sample. And their two heights are 54 and 56. So what we did to get the 6 possible samples is we did 1 2, 1 3, 1 4, 2 3, 2 4, and then 3 4. We paired person 1 with every person under person 1. We paired person 2 with every person under person 2. And we paired person 3 with every person under person 3. So now we have our 6 possible samples. Now we can find the mean of each possible sample. To do that, we just have to add the two numbers in each sample and divide the total by 2. We'll start with sample 1. So to get the mean of sample 1, we just add 50 plus 52. The total is 102. Divide that by 2, and we get a sample mean of 51. Remember that the symbol for sample mean is x bar. So this is just saying that the sample mean is 51. The mean of sample 1 is 51. And to get the mean of each other possible sample, we would just follow the same steps. For each of these other samples, we just add the two numbers in the sample and divide the total by 2, and we get the sample mean. I won't show you the calculator for every possible sample because I think you already know what I'm doing. So if I add these two heights and divide the total by 2, the answer is 52. If I add these two heights and divide the total by 2, it's 53. If I add these two heights and divide the total by 2, it's 53 again. If I add these two heights and divide the total by 2, it's 54. And if I add these two heights and divide the total by 2, it's 55. So I've finished step 1. I found the means of all possible samples of 2 people. The second step for method 1 is just finding the standard deviation of all of the sample means. these 6 sample means make up the sampling distribution for the sample size of 2, and the standard error that we're calculating is just the standard deviation of all 6 sample means in that sampling distribution. So step 2 is find the standard deviation of the sample means. So we'll list out the sample means right here.